Number 1. The vote that changed everything wasn't exactly a scientific consensus. In Prague on August 24, 2006, the International Astronomical Union voted to demote Pluto from the ninth planet from the Sun to one of dozens of known dwarf planets. That sounds official. It sounds like all of science got together and made a big decision. But here's where it gets interesting. Only 424 astronomers out of about 10,000 professional astronomers worldwide actually voted, meaning less than 5% of the world's astronomers decided Pluto's fate. One astronomer at the time said, "I'm embarrassed for astronomy." And it gets even more specific than that. Pluto lost its planetary status in a vote that happened on the final day of their General Assembly meeting. By that point, most of the attendees had already gone home, so the version of Pluto most people grew up with, the ninth planet, the one on every classroom poster, was stripped of that title by a room that was mostly empty on the last day of a conference, by a group representing a tiny slice of the global astronomy community. Pluto Pro Max. It never goes through any of that. It stays a planet, not because the science changed, but because the vote never happened the way it did. And honestly, many planetary scientists don't use the IAU's definition in their published papers anyway. They pretty much just ignore it. So in a very real sense, Pluto Pro Max is just Pluto the way most working scientists already treat it. Number 2, Pluto and its moon don't actually orbit each other the normal way. Most planet-moon pairs work like this. The moon goes around the planet barely moves, and everyone's happy. That's not what happens with Pluto and Charon. Charon is so massive relative to Pluto that the point they both revolve around, called the barycenter, sits in empty space between them, outside of Pluto's surface entirely, so technically neither one orbits the other. They orbit a shared point in space, like two dancers spinning around a spot between them with no one in the center. One of the proposals actually considered during the 2006 debate would have kept not just Pluto as a planet, but added Charon as a planet too, which tells you that even the people doing the reclassifying recognize this system is genuinely unusual. What you have with Pluto is less a planet with a moon and more a double body system, two worlds locked in a mutual orbit. Pluto Pro Max gets full credit for that. Regular Pluto gets filed under dwarf planet, and its bizarre dance with Charon barely gets a footnote. Number 3, Pluto has weather, and it really shouldn't, with the warmest temperatures on Pluto only reaching about negative 360 degrees Fahrenheit. Scientists expected to find a frozen ball covered in craters. That was the assumption going in. A dead cold rock at the edge of the solar system. Then New Horizons showed up and completely broke that assumption. In the northern region of Sputnik Planum, swirl-shaped patterns of light and dark suggest that a surface layer of exotic ices has flowed around obstacles and into depressions, much like glaciers on Earth. And signs of recent geologic activity were found, something scientists hoped to find but didn't expect. The key word there is recent. This isn't ancient frozen history. This is stuff that's still happening. At Pluto's temperatures of minus 390 degrees Fahrenheit, these ices can flow like a glacier, which sounds impossible but is real, because the ice isn't water, it's nitrogen. And nitrogen at those temperatures has just enough give to slowly reshape the landscape over time. Number 4, some of the ice on Pluto behaves like a lava lamp. This one is wild. Inside Sputnik Planitia, that massive nitrogen ice plain sitting in the left side of Pluto's heart shape, there are distinct cellular patterns on the surface, almost like a tiled floor, but made of ice. And those patterns aren't just sitting there. They're being driven by convection. Warm ice rises up from Pluto's interior heat, reaches the surface. It's a slow, churning cycle happening constantly beneath the surface and expressing itself as these polygon-shaped cells you can actually see from space. Nothing else in the solar system does this with glacier ice. It's a process that was thought to require a geologically warm, active world. And Pluto, the tiny frozen dwarf planet at the edge of everything, is doing it anyway. Pluto Pro Max gets recognized as a planet with a genuinely active interior. Regular Pluto gets the same behavior, but since it's a dwarf planet, people tend to assume it's simpler than it actually is. Number 5. Pluto's color comes from its atmosphere, not its surface. Before New Horizons flew past, scientists had some general models of what Pluto's atmosphere looked like. Those models were wrong in a pretty significant way. The haze extends at least 100 miles above the surface, 5 times farther than the models predicted. And this haze isn't just sitting there doing nothing. It's the reason Pluto has a reddish tint at all. When sunlight hits Pluto's upper atmosphere, it breaks apart methane molecules. Those broken pieces then recombine into more complex organic compounds called tholins, and those tholins drift down onto the surface and give Pluto its distinctive reddish-brown color. So the color you're seeing isn't the surface itself, it's a chemical byproduct of sunlight interacting with the atmosphere, coating the world from above. Number 6. Pluto may have had actual liquid rivers and lakes. This one takes a second to sit with. Right now, Pluto is frozen solid. The surface temperature is nearly 400 degrees below 0 Fahrenheit. Liquid anything seems completely out of the question. Real liquid, moving across the ground, on a world that is now completely frozen. New Horizons found ancient nitrogen riverbeds and lakes, and meandering canyons at the North Pole. They're visible features on the surface that look exactly like what you'd expect from liquid that once flowed and then froze in place. Pluto Pro Max is a planet with a geological history that includes liquid surface features. Regular Pluto has the same history, but it's filed under the same category as a small rock floating in the Kuiper Belt. Number 7. Pluto has sand dunes, and that makes almost no physical sense. Sand dunes require wind. Wind requires atmosphere. And Pluto's atmosphere is so thin, roughly 1/100,000th of Earth's atmospheric pressure, that it shouldn't be able to move anything on the surface. And yet, stretching across the edge of Sputnik Planitia, there are hundreds of dune-like ridges that look exactly like wind-formed dunes. Scientists think what's happening is that nitrogen ice is sublimating directly from the surface, turning from solid to gas. And that process is just barely enough to lift tiny methane ice particles and carry them a short distance before they settle back down. Pluto Pro Max is a planet where even the atmosphere, thin as it is doing something. Regular Pluto has the same dunes, but the dwarf planet label creates a mental image that doesn't match the actual complexity of what's there. Number 8. Charon has a red pole nobody fully understands. Pluto's largest moon, Charon, has a dark reddish cap on its north pole called Mordor Macula. The leading explanation is that gases escaping from Pluto's atmosphere drift over to Charon. The two worlds are chemically connected across the space between them. This kind of interaction between a planet and its moon is something we've seen hints of elsewhere in the solar system, but the scale and mechanism here are unique. Regular Pluto has the same relationship with Charon, but again, it's a dwarf planet with a moon, not a planet with a moon, and somehow that changes how seriously people take it. If you're finding this as wild as I do, drop a comment below. I genuinely want to know which one of these surprised you the most. And if you want more videos like this, subscribing actually helps more than people realize. It tells the algorithm this is worth pushing to more people, which means more of this kind of content gets made. Number 9. Pluto is slowly exhaling into space, but slower than expected. New Horizons found a trail of ionized gas streaming away from Pluto for tens of thousands of miles, a sign that the dwarf planet's atmosphere is being pushed out to space by interaction with the solar wind. That part wasn't surprising. What was surprising is the rate. It's not escaping as fast as scientists expected, leading them to believe that the frigid cold of the upper atmosphere is somehow slowing the process. So the extreme cold that makes Pluto seem inert is actually acting as a kind of throttle on its own atmospheric loss. The very thing that makes Pluto seem dead is also the thing protecting what little atmosphere it has. Pluto Pro Max is a planet that's losing its atmosphere in a way that defies the simple predictions. Regular Pluto is doing the exact same thing, but it's hard to get people excited about a dwarf planet's atmospheric physics when most people still think of it as just a cold, boring rock. Number 10. Pluto's heart is running the entire planet. Nitrogen ices in Pluto's heart-shaped Tombaugh Regio go through a cycle every day, subliming from ice to vapor in the daytime sunlight and condensing back on the surface during the frigid night, and each round acts like a heartbeat, driving nitrogen winds that circulate around the planet at up to 20 miles per hour. That one feature, that heart-shaped region, is the engine of Pluto's entire atmospheric circulation. Pluto's heart actually controls its atmosphere circulation. Pluto's heart is a vast, million-square-mile nitrogen glacier, and its left side literally forced the dwarf planet to reorient itself so that the basin now faces almost squarely opposite Pluto's moon Charon. The only real difference between Pluto and Pluto Pro Max is a room of 424 people in Prague in 2006, on the last day of a conference, deciding what the word planet means. The science didn't change. The world didn't change. Just the label did. And the label, it turns out, changed how seriously people take one of the most genuinely strange and complex objects in the entire solar system.